Beneath your feet, in places you've walked 100 times without a second thought, the ground itself might be hiding a fortune. But gold-rich soil doesn't announce itself with glitter or shine. It whispers through color, texture, smell, and the company of certain minerals. And if you can read these whispers, you can find gold in places where others only see dirt. Today, we're going to uncover exactly how to do that, step by step, anywhere in the world. From dense jungles to arid deserts, from riverbanks to mountain ridges, you'll learn the unmistakable clues that transform ordinary earth into a prospector's treasure map. Step 1. The color code of gold-bearing soil. One of the first and most reliable clues to gold-rich ground is its color. Gold is rarely found in isolation. It occurs in association with iron, manganese, and other minerals that stain the soil in distinctive ways. Look for deep reddish-brown soil, a strong indicator of oxidized iron minerals such as hematite and limonite. These often form in the same environments as gold-bearing quartz veins. Mustard yellow to ochre hues suggests the presence of jarosite or goethite, secondary minerals formed in acidic, oxidized environments where gold can also be liberated. Black or blue-gray patches, often linked to manganese oxides. These are common in weathered gold-rich quartz and placer deposits. In goldfields worldwide, from the outback of Australia to the creeks of Alaska, prospectors learn to trust their eyes first. Subtle changes in soil tone can be the first clue that something valuable lies beneath. Step 2. Soil texture and density. The feel of soil between your fingers can reveal more than you think. Gold-rich soils often contain heavier minerals, creating a denser, more compact texture compared to surrounding ground. Signs to notice: heaviness. Scoop up a handful of damp soil and compare it to nearby patches. Gold-rich ground, loaded with iron oxides and heavy sands, will feel weightier. Gritty consistency. Fine quartz particles, black sand, magnetite, and mineral fragments create a coarse, grainy feel. Clay-rich layers. In placer gold areas, heavy clays can act as a trap layer, locking gold particles in place. By training your fingers to feel the difference between ordinary soil and mineral-rich earth, you can detect gold-bearing zones even without seeing them. Step 3. Mineral indicators in soil that holds gold often contains other indicator minerals that are far easier to spot. These minerals can survive erosion and travel with gold in streams, hillsides, and ancient riverbeds. Key indicators include magnetite, black sand, a strong sign in placer areas. It's heavy, magnetic, and often settles in the same places as gold. Hematite and limonite, rust red and brown iron oxides that commonly occur with quartz and gold. Garnets, deep red, glassy grains found in many gold pans, especially in metamorphic terrains. Chromite and ilmenite, dark, metallic minerals signaling ultramafic rocks, which can host gold-bearing quartz veins. In some gold-rich soils, these indicators appear in such concentration that you can see them glinting in the sun. Step 4. Smell and moisture. Experienced prospectors will tell you the earth has a scent, and it can give away its secrets. Metallic smell. A faint iron-like scent in damp soil can indicate high mineral content. Sulfur odor suggests sulfide minerals such as pyrite, which can host gold. Moisture retention. In placer deposits, gold-rich layers often sit just above the water table or in moist zones where heavy particles have settled. Even the way the soil holds water can reveal whether it's part of a gold trap. Step 5. Geographical position. Gold-rich soil doesn't appear randomly. It forms in predictable geological settings. Best positions to check: bends in rivers and streams. Heavy gold particles get trapped on the inside curve of a river bend. Soil here often has high black sand in mineral concentration. Base of slopes beneath quartz. Veins. Erosion washes gold-rich material downhill into concentrated pockets. Ancient riverbeds. Buried channels hold gold-laden gravels that can be identified by distinct, compacted soil layers. Alluvial fans. Cone-shaped deposits at the base of mountains where sediments and gold spread out. Where water slows or soil collects, heavy minerals accumulate. Step 6. The quartz connection. White, milky quartz fragments scattered in the soil can be a sign of nearby gold-bearing veins. In many gold districts, prospectors simply follow the trail of quartz float uphill until they find the source vein. But not all quartz means gold. Look for iron-stained quartz. Yellow, brown, or red streaks from iron oxide weathering. Vein quartz in soil. Large angular pieces that suggest minimal transport from their source. The closer you are to the source, the richer the surrounding soil tends to be. Step 7. Magnetic testing on the spot. You don't need a lab to check for certain gold indicators. You just need a strong magnet. Sweep it over the soil. If black sand or fine particles jump to it, you found magnetite or other heavy minerals. The heavier the magnetic content, the higher the chance that gold is nearby, especially in placer settings. This test is quick, silent, and can save hours of guesswork. Step 8. Layer analysis. When you dig into gold-rich soil, the profile tells a story. Topsoil, usually light and organic rich, not where gold sits. Subsoil, transition zone, often showing increasing mineral staining. Pay layer, dense compact zone with high concentration of heavy minerals. This is where gold particles collect. In river settings, the pay layer often sits just above bedrock, where gold can't sink deeper. Step 9. Erosion clues. Gold moves downhill and downstream with erosion. By reading the land, you can predict where gold-rich soil will collect. Gullies and ravines, natural gold traps during heavy rains. Scree slopes, loose rock from quartz-rich cliffs may mix with gold-rich debris. Drainage convergence points, where multiple streams meet, concentrates form. Step 10. Plant and vegetation signals. Certain plants thrive in mineral-rich soil. Prospectors have long noticed these natural green indicators. Poor or sparse vegetation. High metal content can stunt plant growth. Specific species. In some regions, plants like wild barley or certain grasses grow preferentially on mineralized soils. Unusual colors in leaves. Mineral stress can alter leaf pigmentation. Gold-rich soil often contains subtle signs that only a patient, trained observer can recognize. But perhaps one of the most revealing indicators lies in its connection to ancient waterways. Not all rivers carry gold today, but many soils still bear the imprint of streams that have long since dried up. These ancient riverbeds, now invisible to the untrained eye, can leave behind concentrated pockets of heavy minerals, including gold. You might notice a streak of rounded gravels embedded in otherwise compacted soil, or an unusual mix of sand and pebbles sitting high above any present water source. This is not random. This is the footprint of a vanished river, a silent carrier of gold that once flowed and then retreated. Digging into these deposits often reveals layers of dark, heavy material, sometimes black sands, sometimes reddish gravels. And in those, gold particles tend to settle in the lowest layer. Vegetation can be another silent guide. Certain plants thrive in mineral-rich soils where gold is present. In some gold fields, trees and shrubs show stunted or twisted growth because of the high mineral content. In arid regions, patches of unusually lush grass or certain wildflowers can indicate underground water movement. And where water flows, gold can settle. Observing plant patterns in relation to the soil color and texture can reveal more than hours of blind digging ever will. Even the angle of sunlight can be used to your advantage. When the sun is low in the sky, early morning or late afternoon, fine metallic particles in the soil can glint, giving away concentrations of heavy minerals. Prospectors in the past often used this trick, scanning riverbanks and hillsides at just the right hour to spot a telltale flash. Finally, the most overlooked clue in gold-rich soil is its weight. A simple handful test, scooping up soil and feeling its density, can sometimes be enough to distinguish ordinary dirt from a gold-bearing mix. Soil loaded with heavy minerals will feel noticeably heavier than it looks, a physical reminder that gold's weight works silently in your favor. When all of these indicators align, color, texture, layering, mineral presence, plant patterns, and even scent, you're not guessing anymore. You're reading the ground like a book, one that tells the story of gold's journey through time. The skill is in knowing which pages to turn and which to skip, because the earth is vast and patient, and gold rewards only those who approach it the same way. And so, every grain of sand, every layer of earth, and every glint in the soil tells a story written by rivers, mountains, and time itself. The clues are all around you, hidden in plain sight, waiting for the one who knows how to read them. The earth never speaks loudly, but it leaves whispers in the soil, traces of gold for those patient enough to listen. Remember, gold is never truly lost. It's simply waiting for the right eyes to find it. This is EGS Pro, bringing you the secrets nature tries to keep hidden. Stay curious, stay prepared, and never stop looking beneath your feet.